Welcome students. In this lecture, we'll understand how C++ program can take decisions at runtime using virtual function. This concept is very important because it forms the basics for advanced programming techniques used in real-world software system. Let us begin step by step. What is polymorphism? So, polymorphism means many forms. It refers to the ability of a function or object to behave differently in different situations. In C++, polymorphism is of two types. First is compile time polymorphism, which is achieved using function overloading and operator overloading. Second is runtime polymorphism, which is achieved using virtual function. Today, we will mainly focus on runtime polymorphism. Function overloading and inheritance. Function overloading is an example of compile time polymorphism. Here the function is selected during compilation based on parameters. Inheritance allows a class to reuse properties of another class. However, inheritance alone does not provide dynamic behavior. To achieve dynamic behavior along with inheritance, we use virtual function. Now let us understand a problem. We have a class, we have a base class animal and a derived class dog, both having a function called speak. In the main function, we use a base class pointer pointing to a dog object. When we call speak, we expect dog spots, but the output is animal speaks. This shows that the wrong function is executed. Why this problem occurs? This happens because of early binding. The compiler decides which function to call during compile time. It uses the type of pointer, not the actual object. Since the pointer is of type animal, it calls the animal function. This leads to incorrect behavior. To solve this problem, we use virtual function. Virtual function allows the program to decide which function to call at runtime. This means the decision depends on the actual object type, not the pointer type. This concept is known as runtime polymorphism. So, a virtual function is a member function declared in the base class using the keyword virtual. It can be overridden in derived class. When called through a base class pointer, it executes the correct function based on the object type. This ensures correct and expected output. Here is the syntax of a virtual function. We declare a function in a base class using the keyword virtual. This enables runtime binding. Derived classes can override this function to provide their own implementation. This is the basic structure of virtual function in C++. Let us look at the program example. The speaks function in the animal class is declared as virtual. The dog class overrides this function. In the main function, we use a base class pointer pointing to a dog object. Now, when we call the speak, it points dog barks. This is runtime polymorphism. Why, why, why do we call using a base class pointer? We use a base class pointer to achieve runtime polymorphism. The function call is decided at runtime based on the actual object. If we directly use object like dog d, the function call is fixed at compile time. So polymorphism will not happen. So therefore using a base class pointer is essential for dynamic behavior. When polymorphism happens? Polymorphism happens only under two conditions. First, we must use a base class pointer or reference. Second, it should point to different derived class objects. Only then the program can decide which function to call at runtime. This is a key requirement for runtime polymorphism. Let us see a real world example. we have a payment class with a virtual function pay. Derived class are credit card and UPI. Each class defines its own implementation of pay function. Using a base class pointer, we can switch between different payment methods dynamically. This is widely used in real application. In this example, we have a base class shape with a virtual function area. Derived classes are rectangle and circle. Each class implements the area function differently. Using a base class pointer, we can call different implementation at runtime. This improves flexibility and reusability. Here we have an employee class with virtual function calculate salary. Derived classes are full-time employee and part-time employee. Each class calculates salary differently. Using a base class pointer, we can dynamically call at the correct function. This is a common use case in payroll system. Let us now understand the rules for virtual function. Virtual function must be a member function. They cannot be static. They are accessed using base class pointer or references. They should not be overridden in derived classes. Also, destructor can be declared as virtual for safe memory handling. A virtual destructor ensures proper memory cleanup. When objects are deleted using a base class pointer, the correct destructor is called. Without a virtual destructor, memory issues may occur. So it is always recommended to use virtual destructor in base classes. Thank you, students. In today's session, we learned about virtual functions and runtime polymorphism. Make sure you practice the example discussed in this lecture. Understanding this concept will help you in advanced programming topics. If you have any questions, feel free to ask. Thank you.